Hello, welcome to another video of Engineering Economic Analysis, INEN 2373. In this video, I'm going to discuss how to make a sensitivity analysis and risk analysis using simulation. This is a more advanced topic, but nevertheless, I'm going to simplify it as much as possible so you can understand it and use it to your convenience. So, here we have a project in which the initial investment is $1,000, the minimum attractive rate of return 10%, the life of the project 10 years, annuities are $400 each year, and the salvage value is $150 at the end of the life of the project. When we compute the present worth of this project is 1,516. So what I would like to do now, it's well, maybe my estimation of what the initial investment is going to be, what should the minimum attractive rate of return needs to be, what the life of the project is going to be, and so on, are just estimates. I'm not quite sure if those values are actually going to hold, simply because they're going to happen in the future. So what I'm going to do is I'm going to determine a minimum possible value and a maximum possible value, that it's a bottom value and top possible value for this. And let's say that the minimum investment I could require maybe would be $700, and maybe the maximum could be it doesn't have to be symmetric or anything, but let's keep it within range. So let's say it's 1,300. And the minimum attractive rate of return, the minimum that I want to consider is 8%, but maybe due to inflation and other parameters, maybe that minimum attractive rate of return could fluctuate all the way up to 15%. Let's say that the life of the project at least is going to be 5 years, but if successful, maybe it could extend to 17 years. Let's say that the annuities are right now estimated at 400, but at least we would expect to receive 400, and if we are successful, very successful, maybe it could climb up all the way to 800. Finally, the salvage value would be at the very minimum 100, but at the very top it's not going to climb much, to 160. So let's say that those are the parameters. What we can do is we can generate random numbers associating between those two, minimum and maximum, and Excel has built in that capability. So this is a random instance, and we have ran between, and you can select that. And the first parameter it's asking is for the bottom value, and then separated by a comma the top value. And that's all you need to do, and automatically generates random numbers that are falling within that value. So now that we have those numbers, we can okay, let me see, let's generate a random number. Okay, so once we have those limits on the random numbers, we can generate random numbers in between these two values. When we generate random numbers using the following formulation, we're going to generate a random number, and for that we're just going to select random times the difference between the maximum and the minimum, and to that we're going to add the minimum. The random number is going to be a number between 0 and 1, and then multiply times the range between the minimum and the maximum is going to give you a span that is going to fluctuate starting from the minimum, and that's why we added to the minimum. And we can we have those values as the what the values could be. We can format this number to make it look in percentages, and now that we have these would be possible values for the present worth, for the parameters for present worth computation. So if we think that these are the parameters minimum and maximum, then present worth could actually be $318 if the initial investment is 1,203, which is within the parameters. The minimum attractive rate of return is 13%, in between the parameters. The life fluctuates to 9 years. The annuities dropped from 400 estimated to 294, and the salvage value would drop to 129. So with this, we have one instance of the present worth that it's coming as a random variable. Now the question is, now you see every time you can recompute the spreadsheet, the numbers are going to change, and you can recompute the whole spreadsheet by pressing F9. Some of the values that you see are larger than the average that we had before. Some of them are lower. So now it becomes a problem of, well, what can we really expect? Well, what we could do is we can generate a very nice model in which we're gonna introduce 300. In this little example, we'll introduce 300 instances of the project, and for that I'm making a table of 10 columns and 30 rows, and here at the top corner I make reference to that present value. And now we make use of the data table capabilities in Excel, but now the top row is not making reference to anything in particular, so I select an empty cell, and the first column is not making reference to anything in particular, so I select another empty cell. And when I compute that, you will see that the present words computed are based on the possible random numbers that were generated just like that, randomly. So now this region here has an average, and the average present worth is almost $2,000, and the standard deviation of that region is now $1,272. And you can do other things like computing a histogram and other things similar to that. So you can make an estimation of the risk associated to running this project if you're not sure about the parameters. So however, with all these numbers, now if you recompute the whole spreadsheet, let's say I press F9 now, the fluctuation is not going to be as big as it was for each individual project. The average cancels the very high with the very low, and the fluctuation gives you a better idea of where the real value is going to be. Similarly, the standard deviation, since we have a sample of 300, it still fluctuates, but it's not going to fluctuate as much, and also gives you a risk of where this is going. Actually, what you're going to see is that if you would build a histogram of this data, you would get a similar shape to a bell, and the more samples you have, the closer to a bell shape you would have. So this is a very powerful tool, because with that bell shape you could compute the risk of being less than a particular value in the present value, given the frequencies demonstrated historically in this simulation, and that would give you a measure of the risk of a particular performance in this project.